Okay, we'll get started with one more example to find the Fourier series representation of the given signal x of t. Well, you can see here that we have the x of t, which is given as the combination of two signals, sine of 2 pi by t and the cos of 3 pi by t. So we are supposed to draw the spectrum as well. So let me just try to rewrite it once again for my reference. So x of t is given by sine of 2 pi t plus cos of 3 pi t. So if you try to compare this signal, there are two parts. The first one sin 2 pi t and cos 3 pi t. So comparing with the standard equation, we have the fundamental frequency of the first signal omega naught 1 as 2 pi. And then fundamental frequency of the second signal is, let's say, omega naught 2. Now this is given by 3 pi. And we know that omega naught is the fundamental frequency of the entire signal x of t, and that is given by the GCD of both of these signals, that is 2 pi and 3 pi. So the value of GCD is going to be pi. So we now know that omega naught is nothing but pi radians per second. So let's get started. If I can rewrite x of t in terms of complex exponentials, first of all, sine of 2 pi t can be written as e raised to j 2 pi t minus e raised to minus j 2 pi t divided by 2j plus, let me go to the second term, cos of 3 pi t. So this will be written as e raised to j 3 pi t plus e raised to minus j 3 pi t divided by 2. So I want to rewrite this equation as a combination of separate terms. So the first term is 1 by 2j into e raised to j. I know that omega naught is equal to pi. So I'm going to rewrite them in terms of k times omega naught t. So I will write it as j into 2 into pi t. So obviously the value of k is now 2. Then minus the second term 1 divided by 2j e raised to j into minus 2 pi t. Now if I look at the cos term, I'm going to write this as plus 1 by 2 e raised to j into 3 into pi t plus 1 by 2 e raised to j into minus 3 pi t. Now, if you compare this equation with the synthesis equation we have, now these are the different values of k. K is equal to 2, k is equal to minus 2, 3 and minus 3, and these are coefficients. So comparing this with the synthesis equation, we have x of 2 is equal to 1 by 2j. That is what is indicated here. So that's equal to 1 by 2j. And then x of minus 2 is given by minus 1 by 2j. Similarly, x of 3 is nothing but half, and x of minus 3 has a magnitude of half. So the value of x of k, if it is not equal to 2 minus 2, 3 minus 3, then it's going to vanish. So that condition also I'm going to write it here. So x of k will vanish if k is not equal to, here it is 2 minus 2, 3 and minus 3. So I'm going to write this now. If k is not equal to plus or minus 2 and plus or minus 3. So if the value of k is not this, then it does not exist. X of k vanishes. That's what we have written here. So this is how we try to calculate the Fourier series representation of the given signal. Now, coming to magnitude spectrum and phase spectrum, let's continue here. So the mod of x of 2 is nothing but 1 by 2, and mod of x of minus 2, as you can see here, that is also equal to 1 by 2. And if I look at mod of x of 3, x of 3 is half, so once again its magnitude will be the same. And mod of x of 4, Now this is also equal, sorry, mod of x of minus 3 rather, not 4. Minus 3 is also equal to half. So it's time for me to calculate the values of phase. So I'm going to draw a line here now, and angle of x of 2, as you can see here, that this is going to be um, minus pi by 2, and angle of x of minus 2 is now equal to um, pi by 2. And you can see here that the value of angle for other values of k will actually simply vanish. So if I try to draw the magnitude spectrum, it's going to look like this. So this is the k axis. Here we have the origin, k is equal to 0, 1, 2, 3, it just continues. And in the negative direction, we have the values as minus 1, minus 2, and it continues. So x of 2, mod of x of 2 is given by half. So I'm going to draw a line whose length is equal to half units. X of minus 2 is also equal to half. So I'm going to draw that line now. So x of 3, as you can see, is also equal to half. So I will try to draw one more line, vertical line like this, whose amplitude is once again half. X of minus 3 is also equal to half. So k is equal to minus 3 exists here. So I will try to draw a vertical line like this, whose value is half. So this is the magnitude spectrum of the Fourier series representation. Now, if I come to phase spectrum, I think it's very simple and straightforward. So this is the k-axis. So we have the origin here, and then the value of k ranges from 1, 2, 3, and so on. And in the negative direction also we have these values. And we have calculated the angle of x of 2 as minus pi by 2. So here I'm going to draw one vertical line downwards, whose magnitude is minus pi by 2, and x of minus 2 is pi by 2. So I'm going to draw one more line here with the positive magnitude of pi by 2. So this is the plot of angle of x of k. So the coefficients are x of 2 is equal to 1 by 2j, x of minus 2 is minus 1 by 2j, x of 3 is half, x of minus 3 is also half. So for all other values of k, the Fourier series coefficients don't exist. And this is how we try to plot the magnitude and the phase spectrum. Thank you so much.